Hi there, welcome to STEM for Girls 2022. I'm Neely, and today we're going to be looking at my award-winning science fair project, which actually won my school's science fair, and that is a huge accomplishment for me because there were so many other great science fair projects to compete against. Let's have a look at it. This science fair project investigated whether the length of a swimmer's stroke would increase his or her speed, resulting in a reduction of time. The investigation utilized the scientific principle of fluid dynamics, which is the study of fluids and how forces affect them. This topic was selected because swimming is a popular sport, and reducing one's drag, the forces that slow one down in the water, to drop time is always a swimmer's goal. This experiment was extremely beneficial because its data uncovered whether a small change to a swimmer's freestyle stroke impacted the swimmer's overall freestyle time. The idea was that the relatively easy fix of lengthening one stroke would enable swimmers of all ages and levels of ability to minimize their effort in the water and increase their overall time. The scientific question was initially posed as the following: does the length of a swimmer's stroke positively affect the speed with which they swim? The data overwhelmingly proved that yes, the longer the length of a swimmer's stroke was, the more positively the speed with which they swim was affected. In sum, the experiment's hypothesis was proven correct because by using a longer stroke instead of one that is short and choppy, the swimmer reduces the overall number of strokes and decreases the overall time it takes to swim 25 yards. This experiment ties into the scientific aspect of fluid dynamics, which is the movement of liquids and gases. As a swimmer, one wants to disturb the water molecules in his or her path as little as possible and create the least amount of resistance in the water so as to drop time. When one is in the water, he or she wants to extend their arm as far as possible because a long tapered object slices more easily through a liquid than a short and compact one that creates more turbulent or chaotic strokes. Also, a swimmer wants to make a long, complete, and properly formed freestyle stroke, meaning to extend the swimmer's arm past the head, at which point he or she is pulling force for a longer period of time, and each stroke will get the swimmer farther and will count for more than using turbulent motion, which results in more effort and ultimately takes more time to execute. This last point is shown in Isaac Newton's second law of motion: force equals mass times acceleration. If the swimmer reaches forward in front as far as he or she is able and continues that stroke with a complete follow-through, the swimmer will receive the biggest change in momentum and get more leverage on the water to propel him or her forward. Learning about the scientific principle of fluid dynamics was one of the most vital parts of the experiment. Thank you for watching this segment on STEM for Girls 2022. I hope that if you're a swimmer, you learned a lot about how to increase your stroke and to be more efficient in the water so that you can decrease your time too. Thanks for watching.